3.2, dividing polynomials. So long division of polynomials is set up just like long division of numbers. The dividend goes in the box, divisors out to the left, and the quotient goes up top. Sometimes you will have a remainder, and that's the last line, which is of a lesser degree than the divisor. So we have the division algorithm. If p of x and d of x are polynomials with d of x not equal to 0, then there exists unique polynomials q of x and r of x such that p of x equals d of x times q of x plus r of x. So what that's really saying is that the dividend equals the divisor times the quotient plus the remainder. So for our first example, we have 6x squared minus 26x plus 12 being divided by x minus 4. So we have our dividend, which is p of x, and we're getting divided by x minus 4, our divisor, which was d of x. So let's set it up into p of x divided by d of x. Okay, so we are looking to get x to become 6x squared. So we need to multiply by 6x. Now we multiply both outside factors. 6x times x is 6x squared. 6x times negative 4 is negative 24x, and they have to line up by degree. Long division has a subtract, so we do as well. Distribute the negative, change it to adding. The 6x squareds cancel out. Negative 26x plus 24x is negative 2x. Bring down your plus 12. X times what gives you negative 2? Well, that would be negative 2x. That would be negative 2. So now negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8. And now we subtract. Change your signs. And the two x's cancel. 12 minus 8 is 4. Now 4 is a lesser degree than x, so 4 is your remainder. So we write the remainder. If you were just finding the answer, you could just put plus 4 over what we divided by, x minus 4. If you're writing your answer using the division algorithm, it would be 6x squared minus 26x plus 12 equals x minus 4 times 6x minus 2 plus our remainder, which is 4. Okay, so our next problem, let p of x equal 8x to the fourth plus 6x squared minus 3x plus 1. and d of x equals 2x squared minus x plus 2. We want to find q of x and r of x so that we can finish the division algorithm. So inside the box, put p of x, 8x to the fourth. I'm going to leave a space because we have no third degree. And then plus 6x squared minus 3x plus 1. Outside we're dividing by 2x squared minus x plus 2. 2x squared times what gives us 8x to the fourth? That is 4x squared. Now we multiply 4x squared times the divisor, 8x to the fourth minus 4x cubed plus 8x squared. Subtract, go through and change your signs. The 8x to the fourth cancel. You bring down 4x cubed minus 2x squared. And because we're dividing by 3 terms, we need to bring down the negative 3x. So we're now looking to get rid of 4x cubed, so we need to multiply by 2x to the divisor. 2x times 2x to the second is 4x cubed. It's going to be minus 2x squared plus 4x. And we are subtracting, so we change the signs. Four x cubes are going to cancel. Negative 2x squared plus 2x squared cancels. And then it goes to negative 7x. And bring down that plus 1. Now negative 7x is degree 1. We're dividing by a degree 2, so this is our remainder. So writing our answer using the divisor algorithm, we get 8x to the fourth plus 6x squared minus 3x plus 1 equals 2x squared minus x plus 2 times 4x squared plus 2x plus our remainder negative 7x plus 1. We can use synthetic division for a quick method of dividing polynomials only when we're dividing by a degree 1, something like x minus c. So our example, we have 2x cubed minus 7x squared plus 5 divided by x minus 3. First thing we do is we take the x minus c equal to 0, solve for c. So in our case, x minus 3 equals 0. So x equals 3. So 3 goes on the outside. We put a half box. And then we put in our coefficients in order of degree. We have a degree 3 polynomial, so it goes 2, negative 7. We don't have a degree 1, so we have to put in 0, 5. So you bring down the first one, always. And then we take this outside number, our c value, and multiply. So 3 times 2 is 6. We line it up at the next one and add. Negative 7 plus 6 goes to negative 1. 3 times negative 1 is negative 3. Add them. 0 plus a negative 3 is negative 3. Now we got 3 times negative 3, that is negative 9. Always add. 5 plus a negative 9 goes to negative 4. The last term is always your remainder. And if it's 0, then there is no remainder. Your terms before it, your numbers before it, are your quotients, coefficients. And we just take one exponent away. Okay, so our highest degree was 3. So now we bring down our 2 for the coefficient. It's going to be x to the n minus 1, so the 3 minus 1 is 2. Plus 6x minus 3. And plus a negative 4 over what we divided by, x minus 3. You could also write this using the divisor algorithm. Shouldn't have been a 6, that should have been a negative 1, I'm sorry. Plus the remainder.